In this video, we're going to be solving system of equations using Cramer's rule for 2x2 matrices. First thing that we're going to want to do is establish the rule for Cramer's rule if we have two variable system of equations, or in other words, a 2x2 matrix. We can figure out the value of x and the value of y by looking at a system of determinants. The first one we'll call a of x over a, and for y, it'll be a determinant of a of y over a. Now a, our determinant, is calculated from looking at the values that are inside of our x and y variables, and that will be equal to the determinant of a, b, and c, d. Now remember that a determinant for a 2x2 is a multiplication of these two variables minus the multiplication of these two variables. And if we want to rewrite that, it would be a times d minus b times c. And again, for all 2x2 matrices, it's a multiplication of AD minus BC. Once you've established what the determinant is, we can calculate the determinant of our variable divided by our determinant. Now your A of x determinant is going to be equal to EF and CE. You'll notice that for this, you're not including any of the x variables, and that the columns are reversed when trying to figure out the determinant, with your y values being on the right side and your numerical values being on the left side. Now this is going to be divided by our determinant that we found up above. If we were to write this all out, this will be ED minus CF. And on the bottom, we will have AD minus CB. For A of y, this determinant is going to be equal to AB and EF. You'll notice for this one, it does not include the column of y, and it keeps the columns in order of x and of our numerical values. And again, we're going to divide by our determinant. We can simplify this to AF minus EB all over AD minus CB. When you simplify these, you'll get a single value for x and for y. For this example, let's say we have 3x plus 2y is equal to 6, and we have negative 4x minus y is equal to negative 13. Using Cramer's rule, we're trying to figure out what those values of x and y are going to be. So we'll plug in our theorem for those two determinants for x and the two determinants for y to figure out what those values are going to be. Now our determinant, again, is going to be denoted as a, and it's from the coefficients found next to the variables. That's going to give us values of 3, negative 4, 2, and negative 1. We simplify this by, again, looking at the cross of 3 times negative 1 and 2 times negative 4. When we do that, we're going to get 3 times negative 1 minus 2 times negative 4. So it's going to give us negative 3 plus 8, which is equal to 5. Now a of x, to figure out a, is going to be denoted by our numerical values, 6 and negative 13, followed by our y values of 2 and negative 1. That's going to simplify to 6 times negative 1 minus 2 times negative 13. That's going to be equal to negative 6 plus 26, which is equal to 20. Now remember, this is going to be over our determinant of a, which we found was 5. So x is going to simplify 20 over 5, which is equal to 4. And that will be our x value. Now for our a of y value, or our determinant, is going to be starting with our x values of 3 and negative 4, followed by our numerical values of 6 and negative 13. We'll take the determinant of that, which will be 3 times negative 13 minus 6 times negative 4. That's going to give us negative 39 plus 24, which is going to be equal to negative 15 over our determinant, which we figured out was 5. So that will be equal to negative 3. So our values is going to be x is equal to 4 and y is equal to negative 3. For this example, we're going to have 9x plus 3y is equal to 8, and 2x minus y is equal to negative 3. Now our determinant of a is going to be from our values of x, which are going to be negative 9 and 2, followed by our coefficients of y, which are 3 and negative 1. We'll take the determinant of that, so we'll have negative 9 times negative 1 minus 3 times 2. That's going to give us 9 minus 6, which is equal to 3. Now our value of x is going to be figured out from taking the determinant of a of x over our determinant of a. This is going to be equal to the determinant of our numerical values of 8 and minus 3 and our y values of 3 and negative 1. Again, the columns are reversed for when you're figuring out x. You'll start with your numerical column, and then you'll go with your y value column. If we simplify this, we're going to get 8 times negative 1 minus 3 times negative 3. This is going to give us negative 8 plus 9, which is equal to 1, over our determinant of a, which we figured out was 3. So our answer for a will be 1/3. Our value of y is determined from the determinant of a of y over the determinant of a. Our determinant of a of y is going to be calculated from our values of x of negative 9 and 2 and our numerical values of 8 and negative 3. If we simplify this, we're going to get negative 9 times negative 3 minus 8 times 2. This is going to give us 27 minus 16, which is equal to 11. This is divided by our determinant, again, which is 3. So our answer for y will be 11 over 3. Whenever you're using matrices, it's always good to check your answers to confirm it's correct. Since we have a value for x and we have a value for y, we can plug it into these equations. I'm going to plug it into the first equation, and you can do either or, but I think we'll get much easier values looking at that one. So I'll plug in negative 9 times 1/3 plus 3 times 11 over 3. And that should give us an answer of 8. Negative 9 times 1/3 will give us a value of negative 3. We'll have 3 times 11 over 3, which will give us 11, which does equal to 8, which is equal to 8 on the other side. So this checks out that these are our correct answers. Now what if we have 2x plus 4y is equal to 6, and x plus 2y is equal to 3? Again, we'll calculate the determinant, which is going to be the values of x, which is 2 and 1, and our values of y, which are 4 and 2. If we calculate this out, we'll have 2 times 2 minus 4 times 1, which is equal to 0. When we have 0, we actually cannot solve for a value of x or y. And the reason why is, say we calculate our a of x, we're going to have that determinant on the bottom. And that's going to be for both our x and y values. Because of that, we're going to be dividing by 0. Whenever you have this case, because we can't divide by 0, which gives us a value of infinity, we say there is no unique solution. Now what this means is that we have two different scenarios. If we were to graph it, we could have a scenario where, say, our first equation looks something like this, and our second equation looks something like this. There'll be parallel lines in which those lines do not cross. So therefore, you cannot have a solution. The other scenario is going to actually be where you have your line like this, and then your other line overlapped. Again, this means that you have infinite solutions. No solution, and infinite. From using Cramer's rule, we'll have something over 0, and because of that, we won't really know if it's a no solution or infinite solution, and because of that, for our answer, we'll just write no unique solution. Done. For this word problem, we see that Bob gets gas twice. He spends this amount of money by purchasing a total of 33.5 gallons. We can set this up as a system of equations where we see that he spends $3.96 per gallon at station 1 and 4.05 gallons at station 2. And because this is in dollar amounts, we're going to set that equal to the dollar amount in total, which is 134.28. We also know that he got X gallons and Y gallons for a total of 33.2 gallons. With this information, we can solve using Cramer's rule to figure out how many gallons of gas he got at the first station. So our determinant will be 3.96 over 1 and 4.05 over 1, which will tell us we'll have 3.96 minus 4.05, and that's going to be equal to negative 0.09. Now for this, all we need to do is figure out the value of X, because we want to know how many gallons he got at that first station. So our A of X over A needs to be figured out, and our value of A of X is going to be 134.28 or 33.5 followed by 405 over 1. This is going to be equal to 134.28 minus 33.5 times 405. And that will be equal to negative 1.395. And since this is over our determinant at negative 0.09, we'll divide it by negative 0.09. So our answer for X is going to be equal to 15.5 gallons.